Hey, this video has solutions to some problems from 8.5. I just chose the even ones, so you can have the answers to those, and I think they're a good representation of the different things that you have to do. So if you had problems with the other ones, maybe you can look at these and figure out yourself what was the error of your ways. So starting with number 10, we've got I like to write these things as 1. I don't really like the dx on the top. I think that that's a little bit, I don't know, possibly confusing, that it makes it look like it's something else. So I'd like to move it off to the side. You can put it on the top, it's the same thing, but there's basically a 1 there, right? It's like 1 times dx. All right, so, excuse me, first thing, you need to know how to factor. So x minus 7 and x plus 1. If you feel like you want to have some extra practice factoring, I can hook you up there. But not to... I hesitate a little bit to say this. Thinking about if you did have to do this in a multiple choice situation, if you scanned the answers quickly, I think it would be very obvious to you what the possible factors were, right? If you look at what the answers look like. That's not the only way to get through life, of course. Knowing how to factor is an important skill, as are all the other things you learn in high school. So anyway, it factors to this. So that means that a over x minus 7 plus b over x plus 1 is somehow going to be equal to this. Now if I do my little algebra 2 thing here, this would have to multiply to here. Bx minus 7b would have to multiply to here, all over my common denominator of x squared minus 6x minus 7. You can leave it as factored there. It does not matter, because what we need to do is make this match up to this. All right, so here the coefficients of my x term are a plus b. A plus b. But there ain't no x's, so that's got to be 0. Then the coefficient of my constant is a minus 7b. And that's got to equal 1. So if I solve that system, I'm going to go ahead and just flip the signs in the second equation, like so. Multiply through by negative 1, because then if I add them together, I get 8b is equal to negative 1. So b is equal to negative 1/8. And if a plus b is 0, then a must equal positive 1/8. So that means my original integral is equal to the integral 1/8 times 1 over x minus 7 minus 1/8 times 1 over x plus 1. And those are just straight up linear factors, so that means we've got an antiderivative 1/8 natural log x minus 7. Oops, minus 7. Sorry, that's a minus sign there. Minus 1/8 natural log absolute value x plus 1 plus c. If you want to consolidate these using logarithm rules, you could factor 1/8 to the outside, and then I have this logarithm minus this one. So that's the natural log of this minus this turns into that over that, x minus 7 over x plus 1. You can write it like that. And our buddies at the College Board like to write them like that. They sure do. You can only do this if these have the same factor. Otherwise, you'd have to, if you wanted to do this, you'd have to bring those in as exponents, which is another way of dealing with that. Right? So there's number 10. Number 12. Another straightforward one, if you know how to factor. So let's see what we got here. 5x minus 5 or 3x squared minus 8x minus 3 dx. Oh, on the let's see what on this factor is. So we have to be a 3x and an x, and then at the back it'd have to be a 3 and a 1. The 3 can't go here. If you think about factoring and what you're doing here, if there was a 3 here, it means there you could factor a 3 out of the whole thing here, which means a 3 would have to factor out of the whole thing of this, which it doesn't. So the 3 cannot possibly go here. Pause, reflect on that for a moment. So the 3 has to go there. And then I think we see here, this is a 9 and this is 1. So if I have minus 9 plus 1, that's going to do it. All right, so that means by doing a over 3x plus 1 plus b over x minus 3, I should be able to reconstitute that into this. So that would be ax minus 3a plus 3b times x plus b all over my common denominator. 3x squared minus 8x minus 3. Okay, so that means the coefficients of the x terms, I got a and 3b, a plus 3b. That's got to equal the coefficient of the x, which is 5. And then my constant term, I've got minus 3a plus b. And that's got to equal negative 5. Let's see, how do we want to do this? I could take this top equation here and multiply it by 5. Did I say 5? I meant 3. I said 5 and I wrote 5, but I meant 3. So I'm going to multiply by 3, and that turns the top equation into 3a plus 9b equals 15. And then I can add these together, doing some Gaussian elimination. Right? Poor Gauss. He did so many brilliant things, you know, Carl Friedrich Gauss. And this is probably the thing, the context in which his name is uttered most often. And I'm sure he wouldn't be too pleased about that. Anyhow, so if b is 1, then plugging that back into one of these, like here, say, I think a would have to be 2, right? Check. You can always check quickly to make sure that you did it right by checking your solutions in the other equation. Minus 6 plus 1. Yeah, that's right. Okay, so my original integral now is 2 times 1 over 3x plus 1 dx. I'm writing it as you don't have to do that. I was going to do it as two separate integrals, but there's no reason to do that. And then b is 1. It's 1 over x minus 3 dx. Okay, so antiderivatives here. You've got to be careful here. The 2 can come to the outside, but then when I take the antiderivative, that's going to be natural log 3x plus 1, because it's just a linear multiple. But this is not 1 here, so that means reverse chain rule. I'm going to get a 1/3 on the outside, so that's going to bring the 2/3 there. Plus natural log x minus 3 plus c. There's that. So about simplifying this, because this has a 2/3 in front of it and this doesn't, we might be inclined to leave it like that. I think I would be inclined to. Let's see what the book does, actually. Yeah, the book left it like that. If you really wanted to consolidate it into one logarithm, you could bring this in as an exponent. You could say that that's natural log 3x plus 1 to the 2/3 power plus natural log x minus 3 plus c. And then by logarithm rules, you can consolidate those. Say that's natural log of the product of those of 3x plus 1 to the 2/3 times x minus 3. I don't know that there's any great advantage to doing that, but it's a good idea to just keep our logarithm rules sharp so that when we need to use them, they will be sharp. right? Just like your chainsaw. So 16. Let's see. So here I have a rational expression, but the degree on the top is bigger than the degree on the bottom. This might look like something where you could factor and cancel, but it doesn't work. X minus 1 is not a factor of x squared plus 1. So nothing really that you can do there to simplify it. So I do have to long divide first. So x minus 1 needs to go into x squared plus 1. I leave a space there for the missing x. So x times, that would bring that to the right term so that they will cancel. Being very careful not to make that rookie sign mistake. And that's going to be a 1 there. And 1 times that would be x minus 1. And that gives me a remainder of 2. So that means the original problem is the same as the what we did here is we found a way to rewrite this. It's x plus 1 plus 2 over x minus 1 dx. And then the book, they squeezed a couple of problems in like this. 15 is like this also. At this point, we don't have to do integration by partial fraction decomposition because this is already just a easy integral to do, right? So antiderivative of x is x squared over 2. Antiderivative of 1 is x plus 2 natural log x minus 1 plus c. That's it. The thing that people, I think, tend to mess up in problems like this is kind of losing track of this. Remember that when you do this division problem, this is the sort of answer, if you want, and this is the remainder. So this is equal, this whole thing has to be here, right? Not just this. 2 over x minus 1 is not equal to this. That's just the remainder. This is the, what is it called? The quotient, right? The quotient. All right. Last one of these we're going to do is number 18. I think this one's going to have long division and then a little bit more work. So got x squared minus 3x plus 2 on the bottom. Right? The degrees are the same, so that means I have to long divide first. So x squared minus 3x plus 2 into x squared. There's a chance that you might just kind of see right through this to what it's going to come out to. And if you don't, you might reflect a little bit on what we're going to get as an answer here, but we'll see here. So x squared, it's going to be 1 times this is x squared minus 3x plus 2. Subtract that and I get 3x minus 2 is the remainder. Right? Or the opposite of that. You can think about that. Long division is pretty easy to do in that case. So this integral turns into 1 with a remainder of 3x minus 2 over x squared minus 3x plus 2. So now I can do my partial fraction thing here. But don't forget about the 1. That's still going to be there, right? So here, this factors into x minus 2 times x minus 1. So a over x minus 2 plus b over x minus 1. That's going to somehow resolve back into this. Ax minus a plus bx minus 2b all over my common denominator. All right, so my little system of equations, my a term is going to come from a plus b, and I've got 3 x's, so that's got to be equal to 3. My constant term is minus a minus 2b, and that's got to be equal to negative 2. My constant term. Those are all set up for Gaussian elimination. So minus b is equal to 1 So b is equal to -1. And if b is -1, that means a would have to be 4. Right? Just check them in this equation to make sure that that's right. That'd be -4, and then if there's 1, so that works. Good. All right, so that means, back to here, running out of space, so I'm going to go with the arrow technique into empty space. Not advised, but... all right, so a, that's 4 over x minus 2, and then minus 1 over x minus 1. So that's what all of this turned into, right? That's what all of our algebra. We hadn't done any calculus yet. That was just all algebra. So here, x, oops, I'm doing the antiderivative. What's that doing there? X plus 4 natural log x minus 2 minus natural log x minus 1 plus c. And same as before, same as the last problem, or sorry, 2 problems ago, you can choose to simplify that or not, but if you wanted to, you would have to bring this 4 in as an exponent. So the simplified version would look like x plus the natural log of x minus 2 to the 4th over x minus 1. Something like that, plus c, if you wanted to. I think the book probably has that as an answer. In fact, it's right here, so let me just check. X minus... Yep, they left it like that. There you go. Have a nice day.